So a couple months back, I put together a video about how I made this, which is just a cheap DIY handbrake for drifting in Assetto Corsa. And it just works out really well. It's cheap to put together, simple button, pull the thing, do the skid. What I'm going to do today though is make it better and still stay within that budget price point. For that, I just use this little guy right here, which changes this handbrake from a button input to this analog input. The only hard part is just figuring out how to get this thing mounted somewhere in here so that the action of the handbrake arm is going to move this slider back and forth. The first step in making this modification is to remove the button and figure out what kind of motion the handbrake has on its own. On my setup, the range of the handbrake arm was limited by the button, so I'm not fully sure how far back I'll be able to pull the arm before the spring bottoms out. The other important thing I'm looking for here is how much resistance the spring is providing. If it's too light, then it won't feel realistic, but if it's too hard, I might face problems mounting the whole assembly to the desk later. Once the button is out, the next step is to figure out where to place the slide potentiometer and what you can use to push its lever back and forth. This is probably my favorite part of these projects, as it's just a matter of getting creative and using what you have on hand. I had another one of these large washers and figured I could sandwich the lever between those to slide it back and forth. The last piece of the puzzle is figuring out how to mount the potentiometer. For this handbrake, I'm going to mount it sideways on the inner edge of the assembly. It seems like a convenient place to mount it, and it'll make soldering the wires easier later. Like any real drifter, I'm using zip ties to hold everything in place. The mechanical part is all set now. I've got the handbrake set up where we've got the potentiometer in place, and these little washers here control the movement of the little arm on the slider. The way that it goes now is all electronic. And so you've got these little posts here, and that's what you're going to be soldering to. But the way that you figure out which one's which is by using your multimeter, connecting the leads, and checking for resistance. So the idea, this is a 10K potentiometer, and what that means is there's 10Ks of resistance across the whole thing. So when you find a pairing, it's usually going to be one side versus another, and I think it's this one here, like basically the number 2 prong. If I do it right, it should come back close to a 10 on there. There we go, we got like 9 point whatever. So that tells me that that's the input and the ground. The signal output is going to represent some number in between 0 and 10. And I think that that's this top one right here. So if I hook my little clamps on that, I'm looking for, let's see what we got here as that adds up. Once that settles, I'm thinking since it's probably like 75% of the way over, seeing something around 7 or so would make sense. Let's see, let's give it a little. Alright, so that's holding around 8 something. And the whole idea is like, as you pull it, as you slide it down, that number drops. And that's the signal that's getting interpreted by the chip or by the computer. So all the way down, like 4 something. And then if I bring it back, that number goes up. Bring it back down, number drops. Up, down. Here's our microchip, and it's got 3 inputs here. What I'm using for these wires, the gray is going to be ground, the red is going to be power, and the orange is going to be the signal. So the ground goes to the little dot that says ground, GND, power goes to VCC, and signal goes to A0. I'm just going to solder these on here. And this is the absolute incorrect soldering tool end thickness or gauge of soldering with solder. But this is what I've got, and hopefully It does not ruin everything by using this. After way too much difficulty, everything is soldered up correctly. I've tested the connections with the multimeter, and we're good to go. Let's get this plugged into the computer and programmed to work. Alright, once you're back into the computer, go ahead and plug in the Handbrake to the circuit board and pull up a variety of different websites. The first one being this one here, the Arduino CC. This is going to allow you to download the IDE software that you're going to use to install the sketch. So find the appropriate installer for what you've got. I just use the first one, the Windows installer. What that does is it gets you a program that looks like this. But what you need is the sketch. So you go to this website right here, and I'll post the links for all these in the descriptions. This is AM Studio. That's the guy or gal that has written this sketch and also influenced the design of this handbrake. So go here, AM Studio Projects / Handbrakes, find analog handbrake, and download that sketch. Once you got that, it's going to come to you in a zip file like this. Extract it and copy the joystick folder into your Arduino libraries. From there, you'll open that up, you'll click on this file right here, the INO one, and that's going to pop open that Arduino software piece right here. This part gets a little bit tricky because there's a couple things that you have to make sure that you've got sorted out. Come up here to Tools, make sure that you've got board as Arduino Micro and port as COM5 Arduino Micro as well. Once you got that sorted out, click this little check button to verify the sketch. Once that's complete, click this little arrow button to upload the sketch. Once all that happens, your computer will be able to recognize the handbrake. Finally, to get it mapped, pull up Content Manager, go to your settings in your controls and axis. Mine's already set up, but come over down to handbrake, click on it just like you would before, waiting for input. Give the handbrake a little yank, and it'll hopefully recognize Axle 7 Arduino Micro. Now the other thing that might happen is when it comes off, depending on how you soldered your connections, you might have to invert that invert that input, and then adjust these little sliders here. So I had to set mine from 24% to 68% in order to have a full 0 to 100% range of motion based on how far I'm yanking on the handbrake here. But as you can see, if I leave it alone, it's 0. When I pull all the way back, it's 100%. That is set, so I'll go ahead and save that preset. And now we should be ready to test in the game. Alright, moment of truth. Let's give it a rip. It works.